Just start the board. क्लास ले रहा बाद में चल रहा Okay, so what we have discussed, we have started curves.
Yeah.
Okay, curves. Okay, so we have started with normal distribution. Okay, so that day just I have given you a introduction of normal distribution. Now we'll see it in detail what exactly the normal distribution tells us. Okay. Okay, so normal distribution is generally for a continuous data, continuous data, or if data is discrete, if data is discrete, then it should be in interval form. Why interval form? Because for plotting of, just a minute, Zaid, I'm getting a call. Just a minute. Sorry. Zaid, just a minute. My delivery partner has come here. Just a minute. I'll be back. Huh? 5 minutes, please. Okay.
Got it.
Thanks for waiting, Zaid. I'm back here. Okay. You are there?
Yeah.
Okay. So normal distribution is generally Shani darwaza ban kar. Normal distribution is generally for a data which is in continuous form, okay, or if it is discrete, it must be in interval form, because for plotting of a bell curve of a bell curve we require histogram. We require a histogram, and we know when we have learned histogram, so it is in the type of bins, and the bins are continuous, means touch to each other like this. If you can remember it correctly, they were like this. So this data must be in interval form, 0 to 10, likewise 10 to 20, 20 to 30, 30 to 40, and 40 to, for example, 50. So what we do, we take the midpoints generally and we go to it and plot the bell curve. This is the thing. Okay, so for histogram, the data must be continuous. And if it is not starting from 0, I've told you, you will draw a kink, and then for suppose it is starting from 80. Other than 0, if the interval is starting, it is compulsory to draw this kink. Okay, 80 to 90, 90 to 100, 100 to 110. So if we draw this like this, so then we plot this. So if it is discrete, it must be in interval form, and also in continuous also, it must be in interval form. Interval must is compulsory for this. Did you got that? Okay. So histogram. So normal distribution play a large role in statistics, but they are rather special or not a normal in sense of being. In being the normal density curve shows the overall shape of the distribution. What does it show? Overall shape of the distribution. Okay. So what is the shape? You can note these things down because it is very important. The first thing is the shape. All normal distribution means a data which is possessing a normal distribution, a data which is possessing a normal distribution, possessing a normal distribution. So what is the thing is that the shape is exact a bell curve. The shape is exact a bell curve. Exact bell curve means what does this means? It should be symmetrical, or roughly, or can be stated as roughly symmetrical. Roughly symmetrical. It does not have skewness. Correct? And it must have only one mode. One
Mhm.
mode. It should be
Mhm.
unimodal. Unimodal. You got that?
Yes.
Unimodal means it cannot have two bumps, two bells on it. So this is the thing that he has listed here. See, all the normal distribution have the same overall shape, that's symmetric, single peak, unimodal, and a bell shape. You have seen a bell that
Mhm.
in Christmas that we generally see this bell. Yes or no? This is
Mhm.
for suppose a simple bell. Yes or no? This types the bell. Yeah.
Yes.
So this is the curve that is in shape of a bell. That's a bell. Understood? So it must
Mhm.
be bell shaped. It must have only one mode. Unimodal means what? It should be single peaked. Single peaked.
Mhm.
Single peaked. That's the main thing. Okay. Next is the center. The mean mu is located at the midpoint of the symmetric density curve and is as the same as the median. So the second important thing is that in the normal distribution that I was telling, as it is symmetric, as it is symmetric. So I've told you normal distribution, symmetrical, normal distribution, uh, normal distribution, normal distribution is generally processed by the population data. Population data. It is also shown by sample data also, but the sample must be large. Also for sample data possessing possessing that sample is large. Sample
Mhm.
is large. What does large means in statistics? Remember this. Large means n must be the sample space means data point must be greater than or equal to 30. This is known as large sample. This is known as large sample. These small things no one will tell you. This is known as large sample.
Mhm.
Large sample. This is known as large sample. This is the thing. Okay. So when the data set has 30 data points, so it is known as large sample. That's the thing. So the next thing that is that it should be exactly bell shaped. It must have one peak means unimodal. The next thing is the mean is located exactly at the center of the curve. Exactly at the center. This is possible only in normal distribution. The mu is exactly at the center and mu is equals to every time in symmetrical, we have seen that mean and median is always equal. Yes or no, Zaid?
Mhm. Yes.
Yes. So it is exactly at the center. That's the quality of the mean. So this is the thing. The center, as same as the median, and the variability. I've told you normal distribution, Normal distribution have two parameters. Have two parameters. Wait, have two parameters. The board is not working. Two parameters, and all the things of the normal distribution are ruled by these two parameters. One is the mu, and second is the sigma. Sigma square we say, but we don't generally use sigma square. That's variance. Sigma square, you know, sigma square is variance, population
Mm-hmm.
variance, and sigma, when we take the square root of variance, it is standard
Deviation.
standard deviation. Yes, so this standard deviation is very important. And why we don't use variance, I think I remember that I've given you an example, but I'll show you now also. So this is for, suppose my pen is not working correctly. This is giving me trouble. For suppose this is a bell curve, okay, so this is my mu, okay, this is my mu. So I have told you that day that for suppose sigma, mu is 5, mu is 5, and my sigma is 1. So what I'll do, my first sigma, what does sigma shows? Sigma standard deviation of
Sets.
variability. Yes or no?
Yeah.
So my first sigma,
It sets. Because you're going up by one, so
so
it
it will be
sets.
at, for suppose this is 5, my mu is 5, and my sigma is 1. So this is my first sigma. For suppose it will be 6. Yeah, I have added 5 plus 1, 6. That my second sigma, my first sigma is 6. I don't know why it's not working correctly. It's giving me a harsh trouble, man. 6. Okay. This was to the right. Then it's to the left also. First sigma, it is also known as sigma 1 to the right, sigma 1 to the left. So this is, it will be 4. Then I'll take one more sigma to the right, that will be 3, and one more to the left, that will be 3, and one more to the right, that will be 7. This is known as sigma 2 to the right and sigma 2 to the left. And the third one will be generally to the left 2, and to the right it will be generally 8. That's known as third sigma to the right, third sigma to the left. So between 4 and 6 I am talking about now. Between 4 and 6, this here in the first sigma, in first standard deviation, how much data points data lies? 67% of the data, means 67 percentile, 67 percentile of the data, of the data, of the data, of the data is between the first standard deviation. Okay. Deviation. Okay. Next is about the second standard deviation. That's from this is the total second deviation which I'm drawing curve. So how much data lies in? Can you remember it? I've told you. Yes, Zaid, do
How
you
many
remember
what?
how much data
Then
lies between the second standard deviation? 67 lies between first. Okay.
yeah. I
95%
think
lies
it's
between,
it's it's 68 lies in the first, 95 lies in the second, and 99.7 lies in the third.
95% means 97th percentile of data, 97th percentile of data, of data lies in the lies between the lies between the second standard deviation and, okay, and the third standard deviation, that's according to this whole, okay, this whole till 8, that's around 99.7% of data. And the region that's left here, here on the both the sides. Here lies around 0.3% of data. 0.3% of data.
Mm.
Okay. These are the two regions. Did you got the normal distribution, complete normal distribution?
Yeah.
Correct?
Yes. Yes. Yeah.
All about variability. And in this figure, I'll take it on the board. We will study kurtosis also, I think so. It is there in your book or not, I don't know. But one more parameter is there known as kurtosis. Okay, see. So here, if sigma is greater, sigma, see, pen is not working, man. What is happening? The sigma, if it is, if it is greater or large, greater means I'm large, then there is more variability in the graph, in the graph. And you can look at the first graph, how more variability is there here. See, this is the mu, and this is our first sigma. Yes or no, Zaid?
Mm.
So this is our, see how large is this, the deviation, the what you may say, the data point, this standard deviation, how far it is. And in this case, how closer it is to the mean. Yes or no, it is closer or not?
Mm-hmm.
Yes, this is how the sigma is closer in this case, and here it is far in this case. Why? Because sigma here is large and here sigma is small. That's the reason it is here the standard deviation is more closer to the mean. More standard deviation, sigma is more closer to the mean. That's the thing. Sigma is more closer to the mean. This is why. That's the reason. So there is one topic when we study skewness. Skewness, what does it mean? Skewness. Skewness we have seen. Skewed to the right. Skewness have two terms generally. When there has no symmetry, there is skewness. So there is two, skewed to the right and skewed to the left. There is one more parameter in statistics that known as kurtosis. Kurtosis. Okay, so I'll think I don't have to teach you this because it's not that, just I'll give you the introduction. See, how is this peak? The peak of the first one is somewhat like bended. Yes or no? Why it is bended? Because the sigma is far away from the mean. Yes, correct. And in the second one, the peak was more larger because sigma was more closer to the mean. This is known as mesokurtic
Mm-hmm.
and this is known as leptokurtic. That leptokurtic. This is known as kurtosis. Is it there? You have seen this thing when you have studied this in your school? Kurtosis. Have you
Mm-hmm.
heard about it?
No.
No. So no need to study that. Just have for information. I've told you. When the bend is there, more bend is there in the curve. It is known as mesokurtic. When the peak is more large and it have a what you may say peak, more greater peak. When it is not bended, it is known as leptokurtic. Leptokurtic. We can see here. I will show you one thing on this. See, kurtosis. See, this is the case. See, when there is more peak, it is known as leptokurtic. When it is a bended one, it is known as mesokurtic. And when it is more bended, then it is known as platokurtic. Platokurtic. This also is that is not used much in statistics, but it is a term related to skewness only. So I have shown you. Okay.
Mm-hmm.
Now to the next topic that we'll go. Theory is more in this case. Okay. So we'll read the theory part. You can estimate sigma by I on a normal curve. Here's how imagine that you are skiing down a mountain that has a shape of a normal distribution. At first, you descend at an increasingly steep angles as you go out from the peak. Fortunately, before you find yourself going straight down, the slope begins to get flatter rather than steeper as you go out and down. The points at which this change of curvature takes place are located at a distance of sigma. Means what? What is telling? Telling that if you are climbing a mountain, okay, so for example, this is sigma 1 and here it is sigma 1. Okay, so when you climb from this, when you will reach sigma 1, the slope, the slope as you are climbing, this is sigma 2. As sigmas are changing, the slope will also change. Slope of the mountain will change. Slope
Mm-hmm.
of the mountain
Mountain will also change.
will change. Why it is changing? Because the height of the mountain is increasing, and as the height of the mountain is increasing, it is moving from, for example, this is sigma 1, okay, sigma 1, and this is
Mm-hmm.
sigma 2. So the sigma 2 is it is going to from sigma 2 to sigma 1, okay. So the slope is increasing, and you have reached at the top, that's mu, when you are at the peak, and when you go down, descend, now the slope will decrease as you are going from the higher sigma to a lower sigma. Did you got that, Zay? What he's telling?
Yeah.
Yes, that's the thing.
Yeah.
Okay, so now that's the definition. He has explained everything, and now he has given the definition. So normal distribution, normal curve. A normal distribution is described by a symmetric, means a distribution for which any distribution or any data, any data, any data which have a symmetric and a single peaked and a single peaked single peaked curve with symmetric and single peak curve will and bell shaped shape. That data will be told as that, then shape, then we can say that data is following data is possessing normal distribution. What it is possessing? Normal
Normal
distribution.
distribution.
Yes. When there are three qualities, it must be symmetric. Okay. Single peaked. It must be single peak, and the shape of that must be a perfect bell shape. Bell shape. It should bell shape means it should not have any skewness in it. Means it should not be skewed to anywhere. Okay. So
Mm-hmm.
and the curve, normal curve, and this curve is known as a normal curve. Any distribution is completely specified by two parameters. Here, see, mark this. Normal distribution is completely specified by two parameters, but means normal distribution
Mm-hmm.
has two parameters only. Distribution, I've told you what are the two parameters. That's mu and sigma. Mu and sigma. From this,
Sigma.
and do anything in the normal distribution. These are the main and the perfect parameters that is required for normal distribution. If we know these two parameters, we can plot whole the curve. Yes or no? We can plot or not the whole curve.
Yes.
See, he has
Exactly.
given here the distribution of IBTS vocabulary scores of 7th grade students in Gary, Indiana is modeled well by a normal distribution with mean 6.84 and standard deviation 1.55. What I'll do, I'll take this also and that also on my screen, on my board. So what will help? We'll mark it and look.
Mm-hmm.
That's here. Okay. Uh, and this graph, what they have plotted using these two parameters. He is showing that only sigma and mu are sufficient for everything.
Mm-hmm.
Why it has?
Okay. Got it.
Okay. I want this much. Yes. Okay. See here. See, 6.84 here, 6.84 is the mean. Okay. So he has taken a
Mm-hmm.
6.84 and drawn a green line. which is representing the peak. Okay, and from this peak he has drawn the left hand and he has drawn the right hand. Okay, so where will be
Mhm.
sigma? Where will be sigma? So where is 1.55? So what I'll do, 6.84 plus 1.55. So it will be 9, and it will be 3, 1, 1 and 8. 8.39. See where he has given. The next point that he has marked is 8.39. Yes or no? This is sigma 1 to the right. And if we minus 1.55 from 6.84, so what will be the peak? It will be, I think, 7, 1, it's 9, 2.4, 4.29, 5.29, sorry,
Mhm.
5.29, it is 6 minus 1, 5.29. See here, it is 5.29. Yes or no? Sigma 1, first
Yeah.
standard deviation to the left. Now, again, what I'll do here, add one more
You do the
1.55.
Z model thing to convert it into a normal model.
Correct, correct, correct. Yes, that's good. So it will be 89.9, 9.94. See, the second point that he has
Huh?
plotted on the right is 9.94. So the second standard deviation is here, about here. So this is our standard
Mhm.
second and this is our third. And this is our second standard deviation to the left and third standard deviation to the left. Got it? Zay?
Mhm.
Yes.
Yes.
Yes. So next, come on, read this problem fast. I'll just drink water.
Okay, got it. The mean will be 155 feet. The first standard deviations are going to be 158 and 152. The second standard deviations are uh 161 and 149. And the third standard deviations are 164 and 146. Okay, done.
Correct. Yes. So read it. You're reading very good. Read it. Complete it.
Huh?
Complete the reading.
Yeah, yeah, but I already solved the problem already.
Okay. So see, when we'll add 155, we'll add 3 to 155. It will be 158. So see here. First standard deviation is marked here 158. Then the second standard deviation is 161, and the third is 164. Same as to the left, we subtract 3 from it, and then we draw this normal curve. Did you get that? How to draw this normal curve, Zaid? Or shall we do this
Yeah.
example?
No, I got it.
Yes, that's simple.
Yeah.
Correct. See how he has showed what we need to do. I've told you what we generally need to do. That's simple. Okay.
Mm-hmm.
This is very important. Remember that mu and sigma alone do not specify the appearance of most distribution. Means in normal distribution, I'm telling you, normal distribution specifically, I'll write NDR. Normal distribution generally for can show by mu and sigma, but there are many other distributions. Many normal distribution is the main one that rules statistics. That rules statistics, but there are many other distributions also. Other distributions
Mm-hmm.
also which follows other parameters, which follow other parameters. Okay, other
Mm-hmm.
parameters. It needs to tell that normal distribution follows mu and sigma, but there are other distributions which follow other parameters as well. Okay. So
Mm-hmm.
the shape of the density curves in general does not reveal sigma. These are special properties of normal distribution. Why are normal distribution important in statistics? See, here are three reasons. They can ask you in your exam in the question that why are normal distribution important over other distribution in statistics? So you need to write these three programs. Three reasons. Normal distribution are good descriptions for some distribution of real data. Real real time data means whenever we are collecting real time data, it will follow normal distribution 99% times. Okay, I've told you. You should remember this. Distributions that are often close to normal include scores on tests taken by many people, such as SAT exams and IQ tests, repeated careful measurements of same quantity like the diameter of tennis ball, characteristics of biological populations such as length of crickets and yield of corn. Normal distribution are good approximation to the result of many kinds of chances outcomes, like the proportion of heads in many tosses of a fair coin. Many of the inference methods in chapter 8 and 12 are based on normal distribution. We can say inferential methods. Yes, we are going to study inference statistics, and there are test that tells you that for applying this test, the data should follow normal distribution. So we will see it when we'll be studying the inferential statistics that time. Okay, the empirical rule that I have told you that we have seen it. So what it is here, empirical rule, that in the first standard deviation, what is, we'll read it. Just read this. The figure shows a normal curve. I'm reading from here because it is the question. The figure shows the normal density curve for this distribution with the area of interest shaded. Note that the boundary value 3.74 is exactly second standard deviation. So 3.74 is the second standard deviation below the mean. So calculating the shaded area isn't as easy as multiplying the base into height. What we have done in that curve, the density curve, which was like this, like this, and we were giving the height here. Okay, this was straight. So I've told you there also, here it is straight, therefore for from a specific area to a specific area, we can calculate how much data lies. Yes, we have done one example, you remember that?
Mm-hmm.
Yes, this was considered as the base, this was considered as the base, and this was considered as the height. Correct, this was considered the height, and we generally used to find area equals to base into height, and then we used to tell that this percentile of data lies between this point to this point, 1 to 2. Yes, but here when he has given a bell shaped curve, bell-shaped curve, and when he is giving you one, what you may say, here he is giving that this, he has to find how much data lies here, but it is not simple here to find how much data lies here. Yes or no? But we know
Mm-hmm.
how much data lies here. See, we know, we have studied the empirical rule first only. So in this part, generally, this is what you say, second standard deviation. Correct, second standard deviation.
Yeah.
So here 95% of the data lies, and from year to year and year to year in the second and third standard deviation. This is the second, this is the second, and this is the third, this is the third. So between second and third, 97.5 minus 95%. So how much will be the percent? It will be 2.5%. So means
Mm-hmm.
2.5% data lies between these two. Yes or no?
Yes.
So in one part, it will be half. So 2.5%, 2.5% divided by 2, so it will be around 1.25. 1.25, it is fixed for all normal distribution. 1.25% data will lie, means 1.25th percentile this has, means the area is 1.25. The area will be around 1.25. Got that, Zaid?
Mm-hmm. Yeah.
Area means area will be 0.2, sorry, 0.25, 0.125, 0.0125,
Okay.
0.125, whatever. Okay, so this is the thing. I have explained you all the things. So this is how he has given here. So what percent of area under the normal curves lies within the first standard deviation? Okay, what it is? Just read the questions.
Mm-hmm. Well, what lies within the first standard deviation, then that's 68%.
Yes,
Yeah, 68% is the one that's in within the first standard deviation.
correct, correct, correct. That's great. So we'll see. So what percent of the area under the normal curves lies within the first standard deviation of the mean? So it is around 67 or 68%. That is about the what percent of Gary, Indiana 7 grades have ITBS vocabulary scores between 5.29 and 8.39. Okay. So, what percent of area under the normal curve lies between second standard deviation of the mean? So, it is 95%. Interpret this result in context. What percentage of area lies under the normal curves within third standard deviation of the mean? Interpret this result in context. So, we know how much it lies, 97.5% in third standard deviation. The distribution of
99.97,
the
yeah.
population is approximately normal with mean mu equals to 100 and standard deviation sigma equals to 15. Adjust the applet to display this distribution. About what percent of adults have IQ scores 1, 2, and 3 standard deviation of the mean? So it will be simply 115.
Same.
है ना? So same it will be. So 115. So for suppose this is 100. So it will be 115 here, 115 here, 130 here. This is the second and this is the third, 145. Okay, so this
Mm-hmm.
will be 85, 85, 70, and 555. So this will look something like this. something like this. That's the thing. And this is our mean. Yes or no? Have I
Mm-hmm.
drawn? This is more correctly that I have drawn. This is what you can say sigma. This is sigma. That's the thing. That's correct for the second question. Okay. Adjust the apple to have a mean of 0 and a standard deviation of 1. Now we are moving to standard normal deviation, standard normal distribution, standard normal distribution. This is nothing but just what we do. We apply, we apply, we apply z score for the columns, for the columns which we are, which we are plotting normal distribution. Means what? What when we are doing this here, this we are taking mean as 100. Now we'll take mean as 0. This will be like this somewhat. Okay, this will remain same, but the center will be 0. Center will be 0, and the first standard deviation it will be here 1, here it will be -1, here it will be -2, here it will be 2, and here it will be -3, and here it will be 3. So this is a standard normal distribution. What we have just we have scaled 100 to 0. Just we have scaled down. This is known as scaling down. Scaling
Mm-hmm.
down. How do we
Down.
scale down?
Mm-hmm.
By applying z score. Just remember, by applying z score to the whole columns. And I have given you how to apply the z score to the columns. Yes or no? Do you remember, Zaid?
And mu
Yes, we need to
minus
calculate.
x minus mu divided by standard s
Yes, x minus mu
divided by
divided by
sigma.
sigma. Yes, for the whole column. For every data point, we need to apply this on every data point. So we'll get a standardized score. Standardized score, it is known as. So we get the standardized score, and when we plot this standardized score, plot the normal distribution or the distribution with this standardized score, we get mu as 0 and sigma as 1. We'll see it. We'll see it. One example tomorrow. Okay, so this is here in the third question is telling that adjust the applet to have a mean of 0 and a standard deviation of 1. Then click update. The resulting density curves describe the standard normal distribution. What percentage of area lie under the normal density curve within first, second, and third standard deviation. So it remains the same here.
It's 95, 99.7.
95, 99 here. 95, it will be year 67. Then it will be 95,
I
and it will be
I think
99,
it's
99.9.
that was
Correct, correct. That's the thing.
yeah, that was 68, not 60. Yeah, it is 68.
Yes, sorry, 68. Yes, that's 68. Okay, so 68. So this is the empirical rule. That's the thing. You can write it down in your book. Okay.
Mm-hmm.
So 95% score is this. Then sigma. I'll explain you further only. Yes or no,
Mm-hmm.
Zaid? We have all seen this first.
Yes.
Yes.
Yeah.
The next thing is there is a problem. Come on. Read this. Many students of on automobile safety suggests that automobile drivers must make emergency stops. The stopping distance follow an approximate normal distribution. Suppose that for one model of car traveling at 62 mph under typical conditions on dry pavement, the mean stopping distance means I've applied a brake at for suppose I've marked the point where I have applied a brake. For example, see this is a roadway. Okay, this is a roadway, and for suppose this is my point that I have marked 0. Okay, and I applied a brake and I have stopped here. For example, this is the point 1.23. So how much distance I have required to stop? It is 1.23 centimeter for suppose. Yes or no, Zaid? So this is
Mm-hmm.
marking how much time is required. So conditions on a diagram, the mean stopping distance is after what is the mean stopping distance? 155 feet with a standard deviation of 3 feet. Okay. About what percent of
So
a car,
16%.
correct, what percentage of this model would take more than 158 feet to make an emergency stop? 158. Okay. About
So
what percent of the
16%.
68%? Yes. What percentage of the car this model would take more than 158? More than 158 means this blue part. Yes or no?
Yeah.
So what's this blue part? This is I'll take it here.
half of the 32% left over from 68%.
Correct, 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 correct. Yes, this is 68, whole 68, and we need to find this area. So what we need to do, we have to take 68. How much data is there in the second and the third? So what we need to do is 100% minus 68%. So how much is left? 32. Correct,
32%.
correct. And we need
Mm-hmm.
to see 32 means this part as well as this part. Yes or no?
Yeah.
So, but we are in this part only. So we need to divide this 32% by 2. So it will be
Mm-hmm.
16. Yes or no?
Yeah.
Yeah, that's the thing. See, he has written here. About 16% of the car, 16% of the cars, this model would take more than 158 feet to make an emergency stop. That's the thing. About the 84th percentile, because about, okay. So what's the second question? A car of this model that takes 158 feet to make an emergency stop would be about what percentile of the distribution? Justify your answer.
100
So
minus 16 will be 84.
correct, correct, correct. That's the thing. Yes, means 158 here. This we are interested about this region, whole red and the region to the left of red. So it will be 100 minus 16. That's around 84%. Did you got that?
Mm-hmm. Yep.
So now please check your understanding and all the things. So the distribution of height for young women age 18 to 24. So you can do this example as a homework. Do it. Okay.
Mm-hmm.
Finding areas in a normal distribution. Now it's all about areas in the normal distribution. So how do you find? We have seen how to find the areas. We have done this. Okay.
Mm-hmm.
Areas we have seen. We have seen in the previous example. Then there is standard normal distribution. So see standard normal distribution. See what he has done. He has compared two graphs where the mean was 6.84. He has scaled the mean to 0, and where the mean was first standard deviation was 5.29, he has scaled the standard deviation to the left as -1, and where the first standard deviation on the right was 8.39, he has scaled it to +1. Yes or no?
Mm-hmm. Yeah.
This is possible with the help of the Z score. Please remember this. Z score is the only thing that's do this. Then finding areas from values in a normal distribution. So using standard normal distribution, what proportion of observation is standard normal distribution less than Z equals to 0.54? So we need to look 0.54 minus 0.54. So what we need to do is, how we has done? So recall that standard
Mm-hmm.
normal distribution has mean 0 and standard deviation 1. Okay, so I think we shall see this example tomorrow. Okay,
Mm-hmm. Yeah.
so I'll give you a homework, just read this and we'll discuss the left things tomorrow. Yes or no? Okay?
Yeah. Okay.
Okay.
Mm-hmm.
Tamari. Okay, so tomorrow you'll join
Walaikum
at
salam.
6:30.
What?
Tomorrow you'll join at 6:30, 6:30 a.m.
Yeah. Yeah.
Okay, okay.
Yeah.
So I'll launch the meeting at 6:30. Assalamu alaikum.
Walaikum salam.